Okay, so this video is about sigma notation. What I'm going to do is spend the majority of the time kind of explaining how you can use sigma notation and how it is used. I'm using examples from exercise 3F, question 1, which I appreciate is very easy, but it's quite a good one just to start the teaching off of. So first of all, what have we got? We know we've got sigma. Sigma means add up. And then we've got a number at the bottom and a number at the top. So this is how it works. You take the number at the bottom as your lower bound and the number at the top as your upper bound, and you substitute numbers that travel, all the integers, by the way, no fractions, no decimals, into the piece of algebra that you've got, say, in the bracket or next to the sigma. So let's take the example of 1 to 5 here. If you put 1 into 3r plus 1, you get 4. Similarly, if you put 2, you get 3 times 2 plus 6 is 1 is 7. Then 3 times 3 is 9, plus 1 is 10. You get the idea. You substitute all the time. And because it's a sigma, you add up. Seems incredibly easy. Also, you might want to note that that is clearly an arithmetic sequence. It's going up in threes. And that's one of the things you're going to have to also be able to notice from sigma notation. If you're just multiplying by a number on the letter, like something like 3r, 5r, minus 2r, you are basically doing an arithmetic sequence, whether you know it or not. And you need to know it. Second type is the one that looks a bit like this, where you've got something to the power, and the power is the number that's changing. So here we had 4 times 2 to the minus 1, plus 4 times 2 to the minus 2, and 4 times 2 to the minus 3, all being added up because of the sigma. And the reason why we only needed to do 3 is because you start at 1 and you finish at 3. And that's quite clearly an that's quite clearly a geometric series, because each time you are multiplying by 2. And all I can say on that one is you can see what they look like almost just by looking at them and go, well, okay, look, the first one's multiplying by a number, it's got to be arithmetic. The next one's being raised to a power, so it's geometric. And you can almost just look at it straight away and be able to identify that's the thing you're doing. So hopefully so far so good. I mean, it's not so bad. There can be a few slightly tricky ones, so let me just show you one of those. Here we've got from 7 to 3, so it's not the normal, 7 to 1, you just plug your numbers in or whatever, right? So what you do is you do 7 to 1, and then you subtract 2 to 1. Why? Because if you want 7 to 3, you want what happens when you subs in 3, 4, 5, 6, 7, and then that will work for you. Okay, is that making sense? Now you might go, well, that's trivial, VJ. What's the point of that? Why can't I just do subs in 3, 4, 5, 6, 7 and get on with it? And I agree with you. There are times where that's definitely easier, and the world's not going to end if you do that. Just be aware of that. And I don't think I just want to make a point of that. That there should be a bracket around those that 2 plus 4, because obviously you're subtracting both the 2 and the 4. I apologise for that little oversight there, but you get the idea. So if you've got one that's something like, I don't know, 30 at the top and 10 at the bottom, you do the sum from 30 to 1, and then you'd subtract 9 from 1. By the way, it is 9, not 10, because it says you're allowed in that sigma to be 3. You can be 3, 4, 5, 6, 7 in terms of what you're substituting in. So I hope that makes sense so far. I'm going to add just a tiny bit about some certain rules that you need to sort of just know, but there's not a lot more to this. Okay, here are a pair of specific cases. Now, I mean, it's not, I think, absolutely necessary to memorize these, though these are a good shortcut. First one's really obvious. I mean, if you've got basically 1, or any other number for that matter, all you're going to do is get a series of that same number repeated over and over again for every term. Now, I'm not saying that sigma, say, 6 is also n. It's not. But what I'm saying is the idea behind it is the same. So here we have from 1 to n, and a sigma 1. So you'd have however many 1s there are would be basically however many numbers there are between 1 and n. So obviously the answer would just be n, because you're doing 1 plus 1 plus 1 plus 1 n times. Obviously if it was 6, it would be 6n, logically, because you'd have however many 6s n times added all together. Second one's slightly harder, but again, it's not a thing you need to stress too much over. You can probably work this out in an exam if you really had to. If you had one, for example, the second one would look like, it would be 1 plus 2 plus 3 plus 4 plus 5 plus 6. The actual formula for the sum of that is n plus 1 over 2. And where that comes from is a simplification of the arithmetic sequence. This is the SN formula that you've learnt in previous videos. You don't need to stress about it too much, but they are listed as specific cases in the textbook, so I thought it's worth my while to show them to you. So I'll give a quick example on this. If you wanted to add the first 4, so suppose it was r equals 1 and n is 4, 1, 2, 3, 4, you'd go 1 plus 2 plus 3 plus 4, yeah? So obviously, let's play that in the formula. You get 4, and then you get 5, because 4 add 1 is 5. 4 times 5 is 20. 20 divided by 2 is 10. And guess what? 1 plus 2 plus 3 plus 4 does equal to 10. All right? So I hope that makes sense. I'm going to finish off one more video, and then that's that for the entire chapter. An email will come right.